who would be able to, who in here would be able to be dropped off in the forest with a compass, blind, like you wouldn't see where they drop you, just blind, just, would you be able to use a compass to find your way out? No? I think that's a skill that should be taught more, but you might say we don't have many forests anymore, so, and I have my phone, so why would I do that? I still think it's cool to know. All right. I spend a lot of time in the forest, so one of the things I do, I shouldn't record that. It's nothing to do with the lesson. You need to be aware of it as you walk in. Compass directions. Sorry, one more thing. That's all I'm saying. Anyways, compass directions. In some cases, you'll be given compass directions. So example, south 30 degrees west. This essentially gives you the direction of one of the sides of the resulting triangle. It is important to read these carefully since these angles are not always inside the triangle. You should include a compass rose to get started. This is very, very important here. Include compass rose. I would strongly recommend you always having your, this is a compass rose right here, this, okay? You have your north, south, east, west. And some students mix up east, west. North, south, we're doing pretty good. When it comes to east and west, some of us mix that up. I don't know what your teachers did to teach you that. Never eat soggy wieners, I don't know. But I just focus on this one. It should spell we, not you, right? If it's EW, ew, don't do it. It has to say we, right? So remember that. So how would I, if somebody gives me this compass directions, like, hey, head out in this direction, how would you actually know where to go? Well, the first letter tells you where to start off of. So you start north, and then you will go 25 degrees towards west. So in here we go north, and then we turn 25 degrees west. And that is now our direction that we're supposed to head in. So see how an angle is formed? So this is your direction. So this reads north 25 degrees west, right? Meaning start measuring from north and turn 25 degrees towards the west. That's what that means. I'm not going to do that all the time. I'm just letting you know when you see this, it means start north and then kind of turn 25 degrees towards west and then just walk a straight line. That's when you're truly heading that way. So let's try a couple more. Oh, I should say that southwest, if it's just southwest, it is actually saying south 45 degrees west. It's exactly like southwest, you would be making an exact 45 degree, like there's a 90 here, right? You would split it exactly in 45, and that's what it really means. If I say southeast, you're going exactly, there's a 45 degree angle on either side. You're splitting that 90 here straight in the middle. That's what that means, okay? It doesn't happen very often. Here's another one, south 15 degrees east. So you start south. I'm going to go further up here to make it, and then I will turn 15 degrees towards the east. Right? That's where you measure from. So there's your direction. So you start right at the origin there and then just head out that direction. This is mainly used for right? When you're flying an airplane or when you're navigating with a ship or a boat, because you can actually do that. You can actually go straight. There's no obstacle, right? So this is used in those scenarios. So that's a 15-degree direction here. Alternatively, I could also give you a direction and you're supposed to give me the reading. Like, how would I tell somebody, it's like, go in this direction? Well, how would you tell someone that? Okay. And it all lies with where do you start measuring from in this case. In this case, the direction where you're headed is touching this line here. So in that case, it would be east 32. What would follow it? 32 south. Okay. You're starting east. And you're starting from here and then 32 that way. How would you read this? Where do you start? Not west, but you start, in this case, it's north. So this would be north 71 degrees west. Okay, so one is reading it, the other one is actually telling me where would you be going based on the compass rules. Some of you already know this, and that's fine. Okay, so let's put this to the test. Come with me to 60. This is where it gets a bit more complicated, because we're combining a bunch of directions. We're going to turn. We're going to go one way, and then we're going to turn a different way. And that's when our triangle is going to start to form. So here we go. It is impossible to cover all possible scenarios, but you should get a pretty good idea after seeing a few of these. So here's my first scenario. Sketch the following scenarios based on the description. So example, you see a tree that is due east of you. What is that? It means it's exactly east from you, like straight line east. So if this is you, right, then the tree would be exactly east. So we go this way, and the tree is right there. And this is east. You can put down east over here. So that's what that means. And what else does it say? From the same location, you notice that a deer is standing north 40 degrees west of you. Okay, so this is where I actually should have started with a compass rose. Can you do that real quick? So I always like to imagine that wherever you are, you have your north, south, east, west line. Okay, so I'm going to erase you just for a bit. Just put it down a little further down here, or maybe over here. This is you, and you have a compass rose. So this is south, north, and this is west. East we already determined is over here. So north, 40 degrees west, that means that you would start north and then turn 40 degrees west, and that's where you would be looking towards. And we can call that D for deer. Okay? And you put the 40 in there. And now you should be able to see a triangle, right? So the question could now ask, hey, how far is the deer from the tree, for example? So I'll make that a dashed line because it's not yet provided, right? How far is the deer from the tree? So this is what we're asked to solve. Is there a way we can, is the 40, you have to agree with me, okay? 40 is not the whole angle here, correct? No. What angle do I have right here between the north line and the east line? There is a 90 right there. The question didn't tell you that. You were supposed to just know that. Because this line here is straight east. And this is our imaginary north line, so we have a 90 here. Which means that angle Y is going to be what? 90 plus 40. Angle Y is 130 degrees. This angle here, the whole thing is 130 degrees. So I strongly encourage you to always have a clean version after that. Okay. So you would go Y, D, tree, right? You would put the 130 in here. Voila, now you have an angle in there. We don't have any sides, so I can't really do anything with this other than just making a nice diagram. So this is the clean version. This is what I call the interpretation. And a lot of students want to skip the making the clean version. I got this, right? And it gets so messy. This one can get pretty messy where you kind of miss things, okay? So I want you to have a clean version like this, where you transfer over information that you know, and then you work with this one. This is basically the unknown side, right, that they would ask me to calculate. Let's do another one. I used to go right into solving, not a good idea. Okay, so if you ever teach this unit, just get your students to first draw these things out. Okay, so this is the first one, no solving. You travel 12 kilometers in the direction north 30 degrees east. So there's now distance and direction combined. Then you turn, right? You turn and you head north 50 degrees west for 7 kilometers. How far are you from your starting point? So let's see how I do a question like this. I go northeast. So if you imagine northeast, you'd be probably going in this direction, right? Northeast, and then you go northwest when you turn. So it's going to go like this, more or less. So I'm going to start with my starting point is going to start right here with my compass rose. Make one of these. And this is where a ruler is going to be very, very handy. This is where you start. This is my start. And I go north 30 degrees east. So north 30 east. And just travel. You put the 30 in here. And at this point, you turn. This compass rose follows you wherever you are, correct? No matter where you go. So at this point, because I'm told to turn, I need to bring this back. Okay, do this, please. It'll make your life a lot easier. So this is where you turn. And where are we headed now? It says north 50 degrees west. So you start north, but then you turn 50 degrees west. 50. And you draw your line. Oh, I forgot something, right? This line, how long is this line? 12 kilometers. I forgot that. Let's do that. Let me zoom in too. You can tell me if it ever is too small for you to see, tell me. Can you please zoom in? So now you're headed for 7 kilometers in that direction. Now, this is the biggest problem that students have, that I see them make all the time. Students want to perfectly line this up with where they started to make a nice triangle. But the truth is we don't know. We don't know if you're going to line up perfectly. In fact, 99% of the time, you're not going to line up perfectly north-south. So my suggestion to you would be to stop sooner or shoot past. But this is 12 kilometers and this is 7, so I'm going to make this shorter. Okay, so I'm going to stop right here and make this 7 kilometers. This is end. I'm going to call this end. And now the question is asking, how far are we at the end from our starting point? Like, what's the direct distance? Look at my ruler real quick. I won't draw a line just yet. That 30 is like, if you close that triangle, you can tell that that 30 is not going to be inside the triangle, correct? If I made this line, right, it cuts into the 30. So this angle in this corner of the triangle is not going to be 30. It's Friday. You're thinking of lunch, I know. But remember that. A lot of students just want to leave that 30 there. It's not going to stay there. Watch what I'm going to do. What's this line and this line? This is the north-south line, and this is the north-south line. North-south is always parallel, no matter where you go. Would that make sense? So this one and this one, what do we call them? Alternate interior. You're right. If you were thinking that, that's right. So let's do that. Alternate interior, we bring that in. Boom, just like that. Why would you do that, Mr. Erickson? Because I know that these two sides will definitely be forming the triangle. So my goal is to get this one in here. Okay. Is there a way that I can find this angle right now? There's a straight angle. This is 50. This is 30. So what must this inside be here? 100. But do you also see that there's a 90 here and a 90 here? So 90 minus 50 is 40. 90 minus 30 is 60. It still adds up to 100. Okay. I'm just trying to tell you that there's many ways to get your angles. Okay. So let's do the 60, 40, which combines to 100. Regardless of how you do it, you will get the angle if you're careful. But it all starts with alternate interior. They're your friend. Use them, okay? Can I say this? Alternate interior. Let's just do AI, right? Everybody's talking about AI these days. We'll talk about it too, which is very helpful. Now, this is interpretation. Let's make our clean version. This is like the rated R. We'll do the clean version now. Okay, so what I do is I kind of just go like that. And I try to keep that angle. And then this, I try to keep that angle. And then just, and we're going to go S, T, E, right? Start, turn, end. Can I put the 30 in there, Mr. Dirksen? Because look, it's kind of 30. It is, right? No, you're not going to do it. You're going to bring this one in here. This one. Yes, this one you can, because it touches both of the sides that are part of the resulting triangle. You can put the 12 kilometers in here. You can put the 7 kilometers in there. And this is what they're asking me for, right? What law would I use to solve that one? Cosine, just like that. But the cosine law, I know you know how to do it. It's this part I want you to focus on. This is the kicker. You gotta have your compass rose. You gotta make sure you bring angles over using AI. Hopefully you would wish that AI would just solve this for you, right? But you're not. We're not that far yet that we're using AI in this class, other than alternate interior angles. So the solving part, I will just tell you what it is. 14.91 kilometers. Sorry, just write it down so you know if you want to try it, but that's not right now, not my goal. Okay, we're almost done. Almost out of time. So what I'm going to do, and I made this again last night. Watch what I want you to do. Okay, this is the intent of this sheet, because I know students struggle at first with drawing these things. So I'm interpreting these for you, but I want you to cover that up. I want you to read the problem. I want you to see if you could do this on your own. Like if you could actually sketch this thing on your own and then compare to what I came up with. Don't practice yet. One more thing. And then I want you to make a clean version of that, a clean triangle of this here. And I want you to solve for whatever it's asking you for. But I did all the dirty work for you, right? I did this already for you. So there are 4 different scenarios. And I purposely make it that some are sine law, some are cosine law. I did that on purpose. Mr. Dirksen, are these all the ones we're ever going to see? No. But if you go through these 4 questions, you will have a pretty good idea as to how to tackle these, how to approach them. Okay? So that's it for this weekend, this handout. So homework handout, that's what I will write down here.